This is lesson number 10 for Metal Technology, chapter 18, pages 275 to 288. Please make sure that if you need to pause and jot down your key terms, your descriptors, your images, make sure that you do that. Lesson 10 is over heat treatment. Heat treatment is the process of heating and cooling cycles to harden or strengthen metal to resist wear and breaking. The picture up here on the top right hand corner is a picture of a forging furnace. This is an electronic forging furnace. We do not have this technology in our room. We're just going to use the torches to do our heat treating. So we're doing some low-level heat treatment stuff in our class. Heat treatment can be described as an umbrella, so to speak. There are a lot of different parts of the heat treatment process, and one of the things that you can do in heat treating is something called stress relieving. So when you have stress relieving, it's similar to tempering, and we'll talk about tempering here in a little bit, but it's performed primarily to relieve internal stresses. So stress relieving relieves internal stresses. This picture over here on the side is just a chart that shows you where these things are happening. It may be a little bit difficult to see, but this is a temperature scale, and this is the composition of the carbon content in the metal. Hardened steel, or any metal that is going to be hardened, is steel typically with a high carbon content. Another word or term that falls under the heat treatment umbrella, again, heat treatment is the main thing. So you could kind of compare heat treatment to something like automobile. So heat treatment would stand as the same term as an automobile, and then underneath automobile you may have car, you may have a truck, you may have a van, something like that. Heat treatment, one of the things is stress relieving, and another thing is annealing. Annealing is a process of softening metal by carefully heating and controlled cooling. So this picture over here again is just showing where the annealing is taking place. So in this chart, in this graph, you have the temperature on this side, and you have the percent of carbon content in the steel on this slide. Another term that falls under the heat treatment spectrum is something called normalizing. Normalizing is going to occur on this graph. It's going to occur right up in here. Now for this class, this beginning metal tech class, we don't need to worry about the metallurgy too much of how that occurs and where that's going to occur and what that actually means to us. We just need to understand that normalizing is a process where metal is heated slightly above critical temperature and then cooled at room temperature. It does make a difference when you are looking at this thing right here. Cooled at room temperature. That does make a difference. The difference is when you are cooling this thing off, it will change the grain structure inside the metal itself. Something that we can all relate to is hardening. When you look at this picture over here on the right, I selected a picture of a master lock. When you guys look at your master locks, when you leave this class or wherever you're going to go, look at this section right over here that I'm highlighting. Okay, this will say hardened. We all know that a master lock is extremely strong, it's very durable. So those are the strongest locks out there on the market. Hardening is the quenching of iron-based alloys for the purpose of producing superior hardness. So we will have to do that. When we go through and do this on our project, we're going to have to get our project to what we call a critical temperature. The critical temperature is the temperature at which steel will harden. So if you look over here on the right side, this piece of metal, this piece of steel, is at critical temperature. You'll hear me say upper critical temperature quite often, and that's the exact same thing that I'm talking about. I can tell this piece of metal right now, based upon the color of it, is between probably 1400 and 1600 degrees Fahrenheit. When we do our screwdriver blade, when we harden our screwdriver blade, we're going to take it to critical temperature, and we're going to be between about 1200 and 1400 degrees Fahrenheit, just based upon the carbon content that we have in our steel. This next picture up here on the top right is something called quenching. When you are done with your project, when you have it done and ready to go, You always want to make sure that you cool your project off before you walk away. Quenching has to be done at certain times for certain effects. We will only quench our projects in water. You can quench in different things. So it says right here, with elevated temperature by contact with fluids or gases. You can quench in oil, brine, sand, ash, air. There's all kinds of things that you can quench your project in. So you're taking it from a big elevated high temperature of somewhere around 500 degrees up to 1600 degrees, roughly in there. You want to take it down to room temperature so you can actually handle it and hold it. We will do tempering our screwdriver blade. In order to make it a hardened, workable screwdriver, we need to make absolutely sure that we do this process right here. So it's a sequence of reheating a quench hardened or normalized part to temperature below transformation range. So below transformation range, and holding in a temp long enough to produce the desired properties. So the desired properties, what we're going to do is we're just going to basically come over here and we're going to look at this portion. So our screwdriver blade is going to be similar to this knife that whoever made this project. The colors that you need to look at are right here, this brown and then purple and then blue. So the colors in here, this brown strawish color, then this purple color, and then this blue color are really going to be important to us. This is going to be the desired result. That's what we want to make sure our project looks like when we're done with it. The brown tells me that that piece of metal got between 4 and 450 degrees Fahrenheit. The purple is between 5 and 550 degrees Fahrenheit, and the blue is anywhere between 6 and 650 degrees Fahrenheit. So again, you're talking with some high temperatures. The hardest part about getting your project to look like this is when you are using your torch, you are going to make your screwdriver blade, you're going to try to chase these colors up to the end of your screwdriver tip. Once you get those colors there, you have to immediately take your project and quench it. You've got to put it in water immediately. Otherwise, your desired results will not have occurred. Another term in the hardening or heat treatment process rather is something called case hardening. This picture over here is a picture of some type of a mechanism, some type of a door latch or whatever it is, I'm not sure. But this has been case hardened. So on a case hardening bolt, what you have is a process that creates a thin, hardened, wear-resistant layer on the outer surface. This goldish type color tells me that that is case hardened. A lot of the times you will hear it referred to as grade 8 as well. This machine that we have pictured here is something called a Rockwell hardness tester. Rockwell hardness tester does exactly what it sounds like. It will measure exactly how hard the project is. So you would put your project in here and the machine would go ahead and start, and all it does is push down, and as it pushes down it's going to leave a dent or a dimple in the project, and then you take a measurement of how deep that dimple is, and you can kind of compare it to this dial that you have up here. So you get a reading here, you make a note of that, you take your project out, you would measure how deep the depth of that dimple was, and then you would put it on a chart, and you can kind of go through and compare and figure out what degree hardness your project is in. Wrapping up lesson 10, we've got a couple of essential questions. Describe the characteristics of steel by listing as many of its properties as you can. If you need help on this, you can look through the chapter in the book. And can we alter or change any of these properties, and in what ways? So you should have a good understanding of how we can change these properties now based upon going through this PowerPoint. As always, if you have any questions, make sure you come by and talk to me and ask me. Workbook assignments, all that stuff is going to be so the lesson 10 essential questions. To wrap this up, describe the characteristics of steel by listing as many of its properties as you can. And then, can we alter or change any of these properties in any way? So you should know, based upon going through this PowerPoint, that there are ways that we can change that. If you have any questions, you can always stop and ask, or you can view this and watch this as many times as you need. Don't forget to do the workbook assignment involved with lesson number 10 as well.